Any programming language, including MATLAB, employs some form of logic and automation. This is where two important concepts come in: the concept of the if-then statements and their accompanying Boolean logic. Boolean logic can be thought of as checking to see if a set of conditions are true. In other words, if we wanted to check to see if variable x equaled some value, then we would use what are called Boolean operators. In the command window, try the following expressions: x equals 4, gt equals x greater than 4, lt equals x less than 4, eq equals x double equals 4, neq equals x tilde equals 4, or does not equal 4, geq equals x greater than or equal to 4, and finally leq equals x less than or equal to 4. You can see that gt, lt, and neq all return 0, while eq, geq, and leq all return 1. When a Boolean expression, or the expressions you see on the right-hand side of all these lines, return 0, that means that the expression is false. Similarly, 1 means true. Good convention requires that 1 be used to represent true, but MATLAB interprets any non-zero value as true. In this case, gt, lt, and neq represented greater than, less than, and not equal to, all of which are false. X is neither greater than, less than, nor not equal to 4. The other three expressions should follow in a similar manner of logic. You can also combine Boolean expressions with and or operators. Logically, x and y returns true if and only if both x and y are true expressions. X or y, on the other hand, returns false if and only if both x and y are false. Try typing within your window gt underscore lt equals x greater than 4 and x less than 4. leq underscore eq equals x less than or equal to 4 and x equals 4. eq underscore lt equals x equals 4 or x less than 4. And finally, neq underscore geq equals x tilde equals 4, or does not equal 4, or x greater than or equal to 4. Note that only gt underscore lt returns false or 0 because the expression simplifies to false and false equals false. leq underscore eq is true because it simplifies to true and true equals true. eq underscore lt simplifies to true or false equals true. And finally, neq underscore geq simplifies to false or true equals true. Extending on this, we can now define the if statement, which essentially states that if a Boolean is true, then do something. If statements often also have an else if case, and finally an else case, all of which can be seen in the following example. First, open a new script and enter if x double equals 4, f print f if x equals 5, else if x greater than or equal to 4, f print f else if x equals 3. And finally, else f print f else x equals 0, end. Note that the result is that only if is printed if we run the script. This is because the check is sequential. The first if statement is checked. If it is true, then the fprintf line printing if is performed, and x is now 5. The fprintf function prints a string, and the \n represents a new line. The other two cases are simply skipped even though the else if statement is true as well. Now run the program again. X is now 5, and the else if case triggers printing else if and setting x to 3. Run the program a third time, and now you see the else case triggers printing else, and x is now 0. For if statements, know that there can be multiple else if cases, but only one if case and only one else case. Know also that every if statement requires an end statement. Else if and else statements that follow an if statement are assumed to be alternative cases to this if statement and do not require end standards. This also means that else if and else statements cannot exist without a corresponding if function. In conclusion, if statements are essential to automating processes. They follow the general template if condition, then if action, followed by an optional else if condition, else if action, and finally an optional else condition with an else action and an end. Moreover, if statements can be combined to represent any mathematical situation. Boolean operators in general compare two given values and return either true or false. There is no limit to the number of comparisons in any Boolean expression. Furthermore, the if statement is often used in conjunction with Booleans. Using the if keyword signifies a logical comparison, and the program will perform what is after the if statement if the condition returns true. Optionally, following the if statement are the else and else if statements, both of which dictate what will happen in all other cases or certain other cases. Finally, all if statements must end with an end keyword.